Hi, I'm Sumit Gulwani and I lead the PROS research and engineering team that develops technologies for program synthesis. Today I'm going to show you a demo of some of these technologies inside Jupyter Notebooks. So what I have here is a 911 calls dataset that I would like to analyze. This dataset contains details of various 911 calls. So the first step in this analysis is going to be to ingest this data set into a data frame or a table that I can then transform and visualize. This is often done using a popular library, Python library called Pandas, and specifically the read CSV API. So now when I invoke the read CSV API with the name of the file that I want to analyze, it's like something went wrong here. Some error got thrown. So let's look at this error to see what went wrong. Unfortunately, the error isn't very constructive here. So let's take a look at the file that I was trying to analyze. Aha! I see that there is some metadata at the top of this file, and then there is a header row here, and this information needs to be captured appropriately as proper arguments to the read CSV API that we were leveraging. And to make matters complicated, there can be different kinds of delimiters and some weird quoting semantics that I might need to incorporate as well. Now, the Pandas read CSV API has 50 arguments. So instead of going to Stack Overflow or to look at Pandas documentation and figuring out which parameters to use, I can leverage program synthesis to the rescue here. So one of the domains for which we have invested in program synthesis is that of file ingestion, taking semi-structured documents and automatically generating parsing code to lift those semi-structured documents into tables for further analysis. This program synthesis capability has been exposed as the read API here, so codeaccelerator.read, to which I simply pass the name of the file that I would like to lift into a table. And when I invoke this capability, the underlying program synthesis technology goes and analyzes this file and figures out the right parsing code in order to lift this file into a table. So note that this is not any arbitrary parsing code, but this code actually uses the read CSV API that I was trying to use earlier, except that the program synthesis technology has figured out that there are 11 rows to skip, and furthermore that there is a header in the file, and these are the names of the various columns and some other important parameters here. This read capability is extremely powerful in two dimensions. So one, it can not only handle CSV files, but it can also handle fixed width files, log files, custom text files, JSON files, web pages, even PDF documents. Secondly, when the going gets tough, when the underlying input file that we are trying to parse has a very complicated pattern to it and the AI technology cannot decipher that pattern, then instead of letting the user fall off the cliff, the API supports an interactive modality where the user can give some examples, 1 to 2 examples of the various fields in the document. And in many of those cases, then we are still able to generate the parsing code. So in fact, this very experience, where we first try to extract a table from a file automatically and then lift the user into an interactive mode if we fail, has recently been shipped in Power BI for extracting tables from web pages. Now back to our demo here. So this code that has been automatically generated, I can use this code and incorporate it inside my workflow in order to lift the input CSV file into a Pandas data frame. Now the next step in the process is going to be to look at this data frame in order to figure out how to transform and visualize it. The standard mechanism for doing this is a static previewer. So instead we have invested in an interactive grid experience that offers some basic capabilities like sorting and filtering. But even more interestingly, it provides a great user experience for some of our other program synthesis technologies that I'm going to demo to you next. So let me use this interactive grid to view the data that we just read from the CSV file, the 911 calls data set. And what we see here is that there is a date column and there's a time column that reflects the date and time for the various 911 calls that happened. Now suppose I want to figure out when are 911 calls most common, as in what time of the week. Is it on Monday mornings or Wednesday afternoons? To do this analysis, I will need to create a new feature, a new derived column, where I would like to map the date, which is 12/11/2015, into the corresponding weekday, which I know from my calendar is a Friday. I would like to then map this time into a corresponding hour bucket. So let's say a 4-hour bucket, which in this case is going to be 8 to 12 to indicate late morning. Now just imagine how much code you will need to write to take these two strings here, the date and time strings, and to generate this new derived string. And it is at this point of time that I wish this was Excel and I can leverage the Flashfill feature that I built for them 9 years ago. So Flashfill is a popular capability in Excel that allows automation of string transformations. For instance, it can convert first name, last name to last name, comma, first name from simply one example. But unfortunately, this Flashfill capability won't help in this case because here, this is more than a string transformation. This is more than regular expressions. We need to leverage the semantics of dates and numbers in order to do this transformation. Flashfill is a very popular feature though. There are around 1 million invocations in a week. And the user experience is so enticing that it does not prevent people from trying it on tasks for which it was never meant to be. Recently, there was this tweet where someone made big fun of Excel in not being able to auto-complete a task related to date transformations. So someone joked, look, AI is going to take over the world, and this is how Excel auto-completes for me today. Where someone tried to give an example to map DEC into December, and the system auto-completes JN to January and so on. In fact, some people came to the rescue of this feature by saying that this is how months should be named in the first place. But this is the kind of customer feedback that we incorporate in our work here. And now we knew that we not only had to support string transformations, but also date transformations and number transformations and develop program synthesis technologies for that. And this is exactly what we have done. So this Flashfill plus feature that now we have in this notebooks can take this input-output example, where it takes the first date and the first time as input and the new drive column as the output string, and generalizes this input-output example into a program that can automate the task for the user here. But even more than Flashfill, it actually shows you code, the code that can do this transformation. In this case, this is Python code that we have generated. And this is another feedback that we heard from developers and data scientists who said that they do not really like the Flashfill feature because it is too magical. They would like to have transparency with the system, full interpretability. They would like to see the code that is being generated underneath. And this is exactly what we do now. We don't generate any arbitrary code, but we generate readable code that has great educational value as well. So for instance, now you can figure out that if you want to convert a string into a date-time object, how do you go about doing that? I never knew that a date-time object, if it needs to be converted into the corresponding weekday, you have to use this magic sequence of characters %A. Furthermore, you can edit this code as well. So for instance, here instead of 4-hour buckets, you can go ahead and create 8-hour buckets or 12-hour buckets as you wish. Now you can incorporate this code inside your workflow and execute it to compute the new column for your data frame. And now the last step that is left in the analysis is to plot the frequency counts of these different time buckets. And it turns out that if you want to plot the frequencies in the order that is implicit in these time buckets, then again you have to do some complicated data wrangling, which is being done by this snippet of code here. But this is another case where the user can easily describe their intent using natural language, and that's a capability that we are currently exploring to enable visualizations using natural language. But for now, I have this code written by hand, and I can simply execute this code in order to figure out when are 911 calls most common. And now I know that the 911 calls, most common calls occur at Wednesdays, 8 o'clock to 12 p.m. So this was a demo of program synthesis capabilities inside notebooks, and hopefully you got a preview of how program synthesis is set to create a disruption in programming and lead to the next generation of programming, where we can improve the productivity of developers and data scientists by almost an order of magnitude. So if you want to, let's say, share this chart with someone, so you can right-click on this chart, and all that you need to do is to click on this notebook icon here, and it will slice the code to give you the necessary code for creating this chart. So note that it kept the code for parsing the file, for creating the derived column, and for doing the visualization. And it has no dependency on our program synthesizer, which was just used as a design time experience. So hopefully this illustrates how program synthesis can make you accomplish tasks in a few minutes instead of several hours. Thank you for your attention.